If your RAG pipeline is still pulling the wrong chunk from your vector store, the problem probably isn't your embedding model. It's that you're asking embeddings to do a job they were never engineered for in the first place. Every team building retrieval-augmented generation eventually hits the same wall. You index your corpus, embed the query, pull the top 20 results from a vector database, and the output is uneven. 3 results are dead on, 10 are tangentially related, and 7 are noise that confuses your language model downstream. That mediocre top K is not a bug. It is a design trade-off baked into how vector search works. The reflex is to blame the embedding model, swap it out, retune chunk sizes, and rebuild the index from scratch. That helps, but only up to a point. Bi-encoders, the dual tower models producing those vector embeddings, are optimized for speed and scale, not for precision. They were designed to make retrieval cheap, not to make it correct. A bi-encoder encodes the query once, encodes each document once, and compares them with cosine similarity. That separation is exactly what makes vector search fast over hundreds of millions of documents. It is also why the top K is so often mediocre. The query and the document never actually see each other inside the model. This week, ZeroEntropy released Zerank-2, a 4 billion parameter cross-encoder reranker built on Qwen 3, and MarkTechPost published a tutorial walking through how to plug it into a 2-stage retrieval pipeline. The model release itself is small. The architectural pattern it pushes forward is not. To frame this for anyone newer to retrieval pipelines, a reranker is the model you put between your vector database and your language model. Its only job is to look at a small set of candidate documents and decide which ones actually answer the query. It does not generate text. It does not search. It judges relevance. And that narrow scope is precisely why it can be so good at it. A cross-encoder does not embed queries and documents separately. It feeds the query and the candidate document together into a single transformer pass, lets attention flow across both sides at once, and produces a single relevant score. That joint pass is the entire point. It catches relationships that a separate tower bi-encoder structurally cannot see. That joint pass is also expensive, too expensive to run against your entire corpus. So you don't. You retrieve a few hundred candidates fast with a bi-encoder, then re-rank only those candidates with Zerank-2. The expensive model never touches the long tail. The tutorial walks through this 2-stage setup end to end. A bi-encoder pulls roughly 100 candidates from the vector store. Zerank-2 then scores each one against the query and reorders them. The top 5 or 10 go forward to your language model. Everything else is dropped. Think of the bi-encoder as the funnel and the cross-encoder as the filter. You eat a small latency hit, a few hundred milliseconds on a modern GPU, and in exchange you get retrieval quality that bi-encoders alone simply cannot reach. The math is not subtle. And critically, this is not the same as letting the language model itself sort through retrieved chunks. Generation models are expensive, slow, and not reliably calibrated for ranking. A dedicated reranker is faster, cheaper per call, and trained specifically to produce relevant scores you can actually trust. For billion parameters is the interesting choice here. Most production rerankers in the open source world have been smaller. Cohere's hosted reranker, the BGE reranker family, and Gina's models tend to sit in the hundreds of millions to low single billions of parameters. Going to 4 billion is a deliberate bet on quality over latency. That bet says ZeroEntropy is willing to spend more compute per query in exchange for sharper ranking. Whether that trade-off is worth it depends entirely on what you're building and what your latency budget actually looks like in production. For a customer-facing search box where every millisecond matters, a smaller reranker may still be the right call. For internal knowledge bases, legal discovery, medical retrieval, or any agentic system chaining 10 retrieval calls together, precision compounds. The right answer at hop 1 prevents wrong answers at hops 2 through 10. One wrong chunk early in an agent's reasoning chain can poison every step that follows. In those settings, paying an extra 100 milliseconds per query to land on the correct passage the first time is one of the cheapest reliability wins available. Building on Qwen 3 is also worth noting. Alibaba's Qwen series has quietly become one of the strongest open-weight foundations for fine-tuning, particularly for multilingual work. The fact that a research team chose Qwen 3 over Llama or Mistral as the base says something about where momentum currently sits. A Qwen 3-based Reranker should, in principle, handle non-English retrieval substantially better than Rerankers trained on English-heavy corpora. Published evaluations will need to confirm that, but the architectural inheritance points in the right direction. The obvious winner here is the open-source RAG stack. Teams who don't want to pipe every query through a hosted API now have another credible self-hosted option that runs on a single modern GPU. Owning the Reranker means owning the latency, the cost, and the privacy story end-to-end. The other winner is anyone building agentic systems. Multi-step agents are unforgiving. They amplify retrieval errors at every hop. A sharper Reranker pays compounding dividends across the full agent trajectory, not just the first retrieval call. Enterprise teams running RAG against sensitive data are also quiet winners. A self-hostable cross-encoder means the entire retrieval pipeline can sit inside your own network. No queries leaking to a third-party API, no audit headaches, no per-call billing surprises when traffic spikes. The losers are the hosted re-ranking APIs that have built businesses on charging per-query fees for the privilege of better retrieval. Cohere in particular has built a real revenue line on re-rank as a service, and the gap between hosted and self-hosted quality keeps narrowing. When a 4B open-weight model running on commodity hardware approximates the hosted alternative, the pricing power erodes. That doesn't kill the hosted re-ranking business overnight. There are enterprises who will pay for managed infrastructure, SLAs, and not having to think about GPU provisioning. But the differentiation has to come from somewhere other than raw quality. A few honest caveats are worth flagging. The MarkTechPost piece is a tutorial, not a benchmark. It walks through plumbing, how to load the model, how to score query document pairs, how to wire up the two-stage pipeline, but doesn't run head-to-head evaluations against existing re-rankers on standardized datasets like BR or MTB. Until those numbers land, the implicit claim that Zerank-2 meaningfully outperforms the current open-source field is asserted rather than proven. Treat it as a model worth testing on your own corpus, with your own queries, not as a settled result handed down from on high. And as always, your retrieval quality is bounded upstream. A great re-ranker cannot rescue a corpus full of duplicates, stale documents, or bad chunk boundaries. If your chunking strategy is splitting code blocks mid-function or cutting tables in half, Zerank-2 will re-rank garbage more precisely than before. What I'm watching next is whether the major orchestration frameworks, Llama Index, LangChain, Haystack, fold Zerank-2 into their default Reranker registries. That's the real distribution mechanism for any new retrieval component. Adoption, there is what turns a model release into a default pattern. Zooming out, the pattern is clearer every month. The first wave of retrieval-augmented generation was naive, chunk, embed, retrieve, generate. The second wave is engineered, hybrid search combining dense and sparse retrieval, query rewriting, cross-encoder re-ranking, and increasingly, learned routing between retrieval strategies depending on the query type. Each layer adds latency and complexity, and each layer also moves a measurable amount of error out of the system. Re-rankers used to be optional, a nice-to-have for teams chasing the last few points of recall. In any serious production RAG system in 2026, they aren't optional anymore. If you're still running single-stage vector retrieval and wondering why your language model keeps hallucinating around your own documents, the answer probably isn't a bigger model on the generation side. It's a smarter pipeline on the retrieval side. Zerank-2 is one more tool that makes building that pipeline easier, and one more reason the era of treating retrieval as a solved problem is over.